Hey Kickstarter. Now, 9 days ago today, we launched this campaign, and this morning, we got our 600th backer, and we are 70% of our way to our goal. Kickstarter, thank you. Thank you. Now, I bet a lot of you are sitting back watching this campaign and saying, well, the balls are doing pretty good. I bet they're just going to coast on down now, rest on their laurels and watch Kickstarter. That is wrong. We are not resting on our laurels. We are dreaming on our laurels. And we are dreaming big. So, I want to introduce to you our first stretch goals for this campaign. Now, that means if we can go past our original goal, we can reach $100,000 in pledges. We are going to take the most expensive item in a Solar Pocket Factory, which is a $15,000 computer-controlled laser cutter. And we are going to engineer that from scratch, make that as cheap as we possibly can, and release those designs as open source designs, free for anybody to use, make, change, modify, distribute, start a business off of, do anything you want. And then, if we can go past that, if we can raise $150,000, I said if we can raise $150,000 Kickstarter, we're going to take the Solar Pocket Factory and we're going to solar power it. We're going to make machines that make solar that are powered by the solar they make. So, what we need from you is to help get the word out. Tell your neighbors, tell your friends, tell your family, tell everybody about this campaign. And let's make this thing happen. Let's make big things happen in small solar. Now, when we launched this campaign, we started getting a bunch of emails. And that's what I want to talk about for the rest of this update. We got a bunch of emails asking us, well, you boys seem like you got something pretty slick there with that Pocket Factory, but can you tell me some specifics about what you're doing? What are you actually going to do that's better with your Pocket Factory than what they do right now? That's what I want to show you in the rest of this video. I'm going to show you exactly what goes on in microsolar production around the world. I'm going to show you what our machine does right now and what we plan to make it do. And I'm going to tell you why it's better. You ready? Oil shuts. Come on in. The raw material for a microsolar panel is a crystalline silicon cell. This has to be cut up into smaller pieces, and then those pieces get attached together to form a microsolar panel. In traditional factories, this cutting is done with a laser, and it's the only semi-automated part of the entire process.
The laser doesn't cut all the way through the silicon cells, it only scores them, and then the cells are broken apart manually in a delicate process that's easy to get wrong. We're also going to use a laser to score these silicon cells, but we want to do what nobody else has done. Come up with an automatic way to break these silicon cells apart into small pieces, ready to be placed in a solar panel.
The next step is to take these pieces of broken silicon cell, which we call solettes, and assemble them, placing them onto a backing, and connecting them, bottom of one solette to the top of the next. Right now, this is all done by hand, with people soldering wires onto the back, applying double-stick tape, and manually placing each cell onto a backing. In our Pocket Factory, we have automated this entire process. In one step, we pick up solettes, apply solder paste in between solettes to form a series connection, and place them down onto a backing.
Once all the solettes are placed, we pass the whole panel through a heater to melt the solder and form the connections between all the cells at once.
So now we assemble these solettes into a panel, and that panel is actually ready to put out power. But it's not finished yet. The next step is to cover it in either glass or plastic to waterproof it. But before we do that, we got to check and make sure that it's actually putting out the right power. And if it's not, we got to fix it. Not all factories run this check, and not all of them do it right. Often, the check, which is done manually, doesn't test everything, and it's not always accurate. We found 15 to 20% of the panels that came off an assembly line had a problem. This is the first part of our solution. This is an automated tester that, as a panel comes off our assembly line, can drop down 2 probes and make sure automatically that this panel is putting out the right current and voltage. Additionally, we're designing a next generation board that can check every one of the solettes and make sure that every connection is good, and if it's not, pinpoint the exact location of a problem. The next step in the process is encapsulation. This means that you take this solar panel and you cover it either in epoxy or glass. And this protects the silicon cells inside from moisture and corrosion, and it also guarantees that they're strong. This is typically done in traditional factories using a 2-part epoxy loaded into a caulk gun and applied by hand on top of these panels. Now, this epoxy isn't really designed for solar, so after about 2 years, it yellows in the sun. Our approach is to automate this process so we can make a machine that dispenses resin onto these cells, encapsulating them. Now, with the operational expense we save by doing this in an automated way, we can afford higher quality plastics, like this polyurethane solar resin, which will last up to 10 years in the sun, 5 times longer than current cells. The final step is one last quality assurance check with the finished panel before you send it out. Currently, traditional factories do these tests by hand in a pretty uncontrolled testing environment, and so they end up shipping a lot of panels which aren't up to the grade and don't do what they're supposed to do. Our plan is to use that same quality assurance checker that I showed a few minutes back. By using this, we can take just a second to do a test and make sure that all of the panels we ship out of our factory are working right and do exactly what we say they'll do. So, I hope that gives you a better picture of our process. Right now, these panels, this is the current microsolar panel coming off a traditional microsolar line. These are slow, these are expensive, and these are error prone. This is the first panel that came off of our Solar Pocket factory. Right now we've automated about 60% of this process. We're trying to be able to make these 4 times faster than traditional panels. We're trying to make them much more reliable, much more longer lasting, and much cheaper. So, if you have any questions, just keep them coming, keep the comments coming, tell people, help us make this thing happen, and above all, thank you, Kickstarter. Good night.